Hello, and thank you for watching Beyond the Basics of ArcPy.mp. Jeff and I are disappointed we're not able to present this to you live in Palm Springs, but we are very excited that we still have the opportunity to deliver the content via this format. So sit back, enjoy the donuts we've provided, and let us describe to you some new capabilities that have become available to ArcPy.mp that expose more advanced functionality. At ArcGIS Pro 2.4, we've exposed Python sim access. So the sim is Esri's Cartographic information model. Now that sounds fancy, but really all it is a specification for how we persist everything to an APRX that you've created in the application, and how that APRX is read and recreates a project within the application. Now, more than just the APRX, we also have these other X files, like a mapX. You can save a map out to a mapX file, or you can save a layout out to a pageX file. These are simple text files that you can open in a variety of editors, and they represent a JSON structure or JSON format. Now, what Jeff and I really want to emphasize today and demonstrate to you is that you can read these text files and you can start to understand kind of the object-oriented structure in which these classes and properties and capabilities are persisted, because you're going to use that same logic in the arcpy.mp module to get to those properties so you can make some of those modifications. So in the example over here on the right, we have an attributes table or a feature table, and that has its properties and capabilities available to it. So a feature table has field descriptions, and this is a list, so you can have many fields. And those fields have different properties exposed to them, like field name. Some fields may be numerically defined, and therefore you can get to its number format and change some of its capabilities. But again, once you know how to read this, then once we're looking at the arcpy.mp module, we'll see that we can use that same logic. So once we have our layer, we can get to the feature table, get to its field descriptions, in this case the first field, and we're going to change visibility from its current state of true to false. So don't let the name Cartographic Information Model fool you in that you can only really modify things that are like symbology. Anything that's persisted in one of these X files, you have access to. And I'll give some more information on that in a bit. So why are we providing sim level access? Because it provides finer grained access to many of these capabilities that are persisted in a project. When we originally created arcpy.mp, and prior to that ArcPy mapping, we always authored it in a way that, or designed it in a way that it was really used to automate basic capabilities. You know, you want to turn layers on and off and export to PDF. But you want more than that. You want all those little things, all those little settings that are in the application, but we don't expose through this managed API. So having sim access gives you opportunity to get to a lot of those finer grained capabilities. Also, Pro is growing very rapidly. And for us to be able to update our managed arcpy.mp or our curated API, it's not that simple. So by exposing the sim, we're exposing these capabilities to you as soon as the software is released. This has always been available to the .NET SDK community almost since the beginning of Pro, and it's only fair that we make it available to our Python developers. Now, I really want to caution you and this is also explained in the help, you cannot use the sim to do everything. It's not this magical easy button. Okay, you can modify basic simple properties. But currently the sim doesn't provide you access to high-level project properties. So now these are properties that you would set via project options. A lot of that stuff is just not available to you. We only really have access to, like I showed before, maps, layouts, and layers and tables. Metadata can't be gotten to through the sim, but understand at ArcGIS Pro 2.4 or 2.5, I don't remember, a metadata module has been made available, so arcpy.metadata. And through that module, you can get to metadata capabilities. But anyway, there are other examples like changing spatial reference that you just can't really do with the sim because it's really, really hard. So spatial reference is persisted all throughout the sim. It's persisted in maps, associated layers. So if you find the spatial reference properties inside of a map X file, for example, you may think, oh, I can just change it here. But understand that information is persisted in other locations as well. It's persisted in the layers. It's persisted in the default extent. So it's very, it could be dangerous for you to try and go in and modify it in one location, but not appropriately modify it in all of the locations, and therefore you could get the project into a bad state. Another example is renderers on a layer. So for example, if you have a layer that's single symbol, well, the sim is going to persist all those properties about that single symbol. But you can't just simply change it from single symbol to graduated colors or graduated symbols because it's not in the sim. So how would you change it? Because the sim's only describing the original renderer. So it's little things like that that you really need to understand. And as you start to navigate these JSON structures, I think you're going to start to understand that these are the types of things that I can change and I can't change. Now, here, the general rule of thumb for arcpy.mapping since the very beginning in arcpy.mp is that you don't have the ability to create new objects. And we've always said, you know, you got to author everything up front, and then you're going to use the managed API to do basic automation tasks. So if that object isn't in the sim, like the example I said where you don't have the properties for the graduated colors because it's not there yet, it's the layer is currently single symbol, you can't access it. Now I'm going to pause just for a moment and tell you, well, yes, you can, and that's going to be the very last thing that I'm going to talk about was something that we exposed at ArcGIS Pro 2.5. So I will come back to that later on in the presentation. Now, the most important lesson here is there really is no lifeguard on duty, right? When you work with the API or the managed UI or managed API, we're going to block you from doing certain things, right? There are certain states where you may break the behavior of the app because through the API or the UI, we block you from doing contradictory things. But if everything is in the sim, you could potentially create scenarios that just don't make sense, and the application may not behave correctly. So the lesson here is you must test thoroughly. You must create copies of your projects just to make sure that you don't jeopardize getting the application into an odd state. So please test. Now, the basic workflow for working with the sim is really simple, right? So we have these objects, and they're either maps, layers, tables, or layouts. And all we simply need to do is get their definition. When we get their definition, we're returning that JSON structure. And then you do something to that structure, you change basic properties, and then to that object, that map, layer, table, or layout, you set those change sim definitions back to the object. And this is really it. So we're just introducing a couple new lines here, or methods, get definition and set definition. Now on the first line here, we have this version, and it's a required parameter. And at all of the ArcGIS Pro 2.x releases, starting at Pro 2.4, you're going to use V2 or version 2. But the reason we have this is that we use semantic versioning with the sim, and we don't allow breaking changes to the sim to happen until a major release, a .0 release. So it's possible, it may not happen, but it's possible when version 3.0 comes out of Pro, we could make changes to the sim that would no longer work with your old scripts because we made a breaking change. So what we can do is we can specify the version that we want to use of the sim, so that if we're in Pro 3.0, for example, we can still say, hey, use the version 2 specification. So there's really nothing you can do about this now until we start having another major release of ArcGIS Pro. Okay, let me show this to you live. I'm going to switch over to ArcGIS Pro, and what you're seeing here is a project that we're going to make available to you. You'll be able to download this from ArcGIS Online. It has a bunch of views, map views, layout views, but most importantly, it has 30 different scripts that do modifications using the sim in a variety of different ways. We'll talk about this a little bit later. But the workflow is, in this particular case, I want to go in and change some of the attribute visibility and formatting for a feature table. So I have object ID and shape and name and all these extra fields, and you can see that I have shape area, shape length with a lot of extra significant digits. I want to clean that up. And I can't do that through the managed API, so I'm going to do that using the sim. So typically what we do is we're going to take a map, a page X, a LY or X, whatever. We're going to generate that file out on disk. So I'm going to take my layer and I'm going to save it out to an LY or X. So I'll go to my C temp folder and I'll call it Great Lakes, LY or X, and I'll save that. So now let me come back to my temp folder, and I can edit this file in Notepad or any text editor. It's a simple text file, but to save a little bit of time and to show you a shortcut, I'm going to rename this to JSON. Now I've associated JSON with Notepad++, and I like to do this extra little trick because when it opens in Notepad++, I see some better formatting. So I'm going to open this up, and if I go to the very top, we'll see that this is a sim layer document. The layer was created in version 2.5, but as I iterate through the layer definitions or how that layer is described, there's a lot of information here. For example, there's charts, and there's all this information about charts and how the charts for that layer have been persisted inside of this JSON file. And this just goes on and on and on. There's lots of things to be changed. So I'm just going to simply do a Control F, and I'm going to do a search feature table, find next, and this is where we were in the screenshot. So again, our feature table has field descriptions. The first field name is object ID. The second field name is shape, and then there are all these additional properties. So let's go back to ArcGIS Pro and let's follow this object model in the API. I'll go back to Pro, and just so you don't have to watch me type a lot, what I'm going to do is I'm going to actually open up this sample that I'm going to be running as part of the demonstration and as part of the download. I'm going to edit this, And you'll see that this script has everything we need to make those modifications. So what I'm going to do is I'm going to borrow this code right here. And I'm going to come back to Pro, and I'm going to open up the Python window, and I'm going to paste this. So using the managed API, right, I'm going in, using the current project, finding a map called Great Lakes, finding a layer called Great Lakes, which is this thing right here. And then I'm going one step further, right? I'm now then creating a variable called lsim, and I'm going to my layer, and I'm getting its definition, and again, I'm using version 2. So if I type L dot, right, we have all of these capabilities available to us. These are all of the things that we've, by design, exposed to you in our managed API. But if I do lsim dot, you'll see, wow, everything that we saw in that document is now exposed right here. Right? There's charts, so we can get to the chart object, and from the chart object, we can get to a lot of chart properties. If I type feature table, you'll see that I have feature table, and then I can type dot, and I can get to things like, it's field descriptions. Oops, it's field descriptions, it doesn't matter. So let me go back to the actual script and show you what this looks like. All I'm doing is once I get my layer definition, I'm now iterating through every field that is available to lsim feature table field descriptions, right? And as we saw in the JSON structure, right, if our field name property is either equal to object ID or shape, well, we're going to change the field visibility property to be false. So we can very easily toggle or make visible or not visible certain fields in a table. Likewise, we can also get to other things like, or find other fields like shape area and shape length. And what we're going to do is we're going to change its alias to maybe something that's a little bit more readable. And again, because it's numerically defined, now we can get to additional properties like number format, rounding. But regardless of everything we do here, and what we do here is going to be governed by what we can see in that JSON structure. Once we make all of our changes, then we're simply going to apply those changes back to the layer. So I'm going to run this. Let me close this. I'll run this scripts tool. There are no parameters required for any of these. Oh, I accidentally ran it twice, but that's okay. So now what I'm going to do is I'm going to open up the attribute table again. And you'll see that we no longer have object ID and shape. We've made those invisible. And if we move over to the right, you can see that we've modified the aliases of perimeter or shape length and shape area. And we've also changed the formatting to show significant digits, to pad with commas, etc. And also notice that in the layout, because we have dynamic tables, we've also modified that information as well. So what I'm going to do now is I'm going to pass this over to Jeff for more examples, and then I'll come back and talk to you more about creating objects using the sim. So thank you, and I'll hand it over to you, Jeff.
Hello, my name is Jeff Molds. I'm a product engineer based out of Redlands, California. I work on the layout team and the arcpy.mp team. Now for my first demo, I'm going to demonstrate how to make a time map book, meaning for each time slice of a time-enabled layer, I will create a map series page and then stitch all the time slice PDFs together into a map book. Now, ArcGIS doesn't have a concept of a time-based map series yet. Also, arcpy.mp doesn't have any time-enabled classes or functions yet. Since we haven't yet implemented time in ArcPy, we could utilize the sim module. We could dig into the sim to access these time properties. First off, let's look at the ArcGIS Pro project that I'm going to use in my demo. So what I have here is a time-enabled historical data for Tokyo and Beijing that shows how the city boundaries have changed over time. These map frames have time-enabled data. And you can see that if I activate the map frame, and you can immediately see that the time slider becomes active. Also, if I look at the properties of this layer and go to the time tab, you can see that time is enabled. Let's also look at the time ribbon here. In my sim Python script, what I'm going to do is use the sim to read all these properties, like the start time, the end time, the number of steps, etc. I also have some dynamic text that will automatically update on each time map series page. First off is the current timestamp, which is this highlighted piece of text here. Now I created this dynamic text from the Layout Insert tab, Dynamic Text, and Current Time right here. Now these dynamic text elements are super useful to use in your layout as they update based on conditions, such as when the map frame extent changes or the map series page changes or the time changes. So you get dynamic behavior out of the box without having to write any code. I could edit dynamic text elements as well. So if I go to the properties here, I've modified this timestamp to just show me the year. Now this area text is also using dynamic text. Specifically, it's using table statistics dynamic text, which is also created from the dynamic text dropdown down near the bottom. And I'm using the sum statistic. Now to see how this works, click the properties, click this element, and the way this works is for this map frame and for this layer, for the visible rows in the map, give me this statistic, in this case sum, for this field. So my area is actually stored in a field. Okay, let's look at the script that I'm going to use to create my time map book. So in the catalog window, I have a script tool, which I could edit. And let's just walk through this script really quickly. So first off, I create a master PDF file. And this is the final output PDF that will contain all the time step PDFs. Here I reference the project, a layout, and a map. And here I get the sim definition from the map. And then here I start reading the sim time properties. So how do I know which properties to read? Well, as Jeff showed you previously, you could open up the mapx file of the map, which is the JSON structure of the map in Notepad++, and kind of use that as a object model diagram. And I have the map as JSON in Notepad++ right here. And if I look in here, I could see that all the time settings are in this node. So this is basically your object model diagram. So for example, in this script, I want to access the time step interval, which is right here. The other stuff I need is like time units. And in here, I could also get the number of steps and the start time. Okay, so let's go back to the script. So after I read the sim, I'm going to loop through all of the time steps. So first off, I just show some useful messages back to the user. And then I get the layout sim definition. Then I get the Tokyo map frame, and I set the start and end times. Same thing for the Beijing map frame. I set the start and the end times. And then I commit those layout changes. So now my layout is going to show the start and end times. And then I just dump that layout out to a PDF right there. And then I append the PDF to the master PDF. And that was for step 1. And then I go to the next step and do the next time step and do the same thing. At the end, I just save the PDF and open it up. So let's run the script. So we'll go back to Pro. We'll just run this. Now it's a very simple script tool. It doesn't have any parameters. In my example here, I don't need any parameters because I'm just going to read what is on the time ribbon. So I'll run this. And this will run and you should see the map update for each time slice, and then open up the PDF. Now, if I switch to this view, I could see how the boundary changes over time. And you could also see that my dynamic text updated. So we'll go back to the first page here. You could see that the date range updated and also the area. So I'll just quickly go through these pages again. Okay, so that's the end of my first demo. Now I'm going to shift gears here and talk about something completely different. And we're going to look at some cases where the sim module can help us in updating data source workflows. For this part of the presentation, I'm going to use Jupyter Notebooks, which is a web-based Python IDE that ships with ArcGIS Pro, and it's just another way to run Python code. Now, like I said, we're going to be talking about updating data sources. Now, what do I mean when I use the term update data sources? It refers to any scenario where you need to change your layer's data source. Now, the picture here in the notebook shows one such workflow where we're moving from an enterprise test geodatabase to a production geodatabase. In this case, all the layers that are currently pointing to the feature classes in the test environment need to be resourced to the production environment. Now, there's many other reasons you might want to resource your data. For example, you may have gotten a new enterprise geodatabase with a new name, or perhaps there was some sort of folder restructuring of your projects, or maybe all the data was moved from a file geodatabase to an enterprise geodatabase. And you may have any number of projects with any number of layers that need to be updated. And it would be tedious to resource all these layers manually. So this is something you would want to script. In the managed arcpy.mp API, we have methods for updating data sources. And here's the link to the help topic. And let's just quickly look at this. And it's just opening up here. And this help topic has a lot of samples, as you can see. And we're not going to go through these right now, but I just want to show you that there's a lot of examples in here and a lot of code. Now let's go back to my notebook and look at a really simple example using the managed API before we dive into the SIM, just so we could kind of get an idea of what updating data sources is. Now here, example 1 is a basic example of resourcing layers in a project from a file geodatabase to an enterprise geodatabase. So I define a project, and then off of the project object, I call the update connection properties function. And the function is like a find and replace. So I'm going to search for any layers that are referencing this geodatabase, this file geodatabase. And I'm going to resource the layer to this enterprise geodatabase. You can see it's got the .sde connection here. Now, another feature of the managed API is the connection properties dictionary. And the connection properties dictionary is the SIM representation of the layer's data source exposed as a Python dictionary of connection properties. So if we look at example number 2 here, this is a workflow where we are resourcing enterprise geodatabase layers from a test environment to a production environment. In this example, the enterprise geodatabase uses operating system authentication, and the database name is the same. And if the usernames and passwords are the same, the instance and server could be changed without knowing the credentials of layers in the project and without having to create new enterprise geodatabase connection files, otherwise known as .sde files. So we define a set of connection properties to search for right here. So that's my test environment. And we replace them with these new credentials, which is the production environment. And like the previous example, off of the project, I call update connection properties, and we do a find and replace of those dictionary key value pairs. So these connection properties dictionaries are pretty useful. They allow you to read or update any part of the layer's connection properties, including joins and relates. And we haven't even gotten into the SIM yet. So this is a little bit more of an advanced workflow. And now we're going to get into the SIM. So these dictionaries are not a complete solution to all data source workflows. As it stands right now, updating data sources in Python, and even in the UI for that matter, is still a bit of a work in progress. And keep in mind that building an API to update every data source type is a huge undertaking because of the sheer number of data formats supported in ArcGIS Pro and the complexity of all those different formats. And this is where the concept of the SIM comes in. The SIM is there to use as a workaround to functionality that either ArcPy hasn't implemented yet or perhaps never will for more advanced workflows. Now, the next examples are going to use the SIM to do stuff that currently isn't possible in the managed API yet. And we're going to keep looking at this workflow of resourcing enterprise geodatabase layers from a test environment to a production environment. Now, something that you can't do in the managed API is to specify an enterprise geodatabase connection file to search for. And what I mean is we can't specify an SDE connection file as the first parameter, and I have that highlighted in the notebook right here. We could put one in the second parameter, but we don't support this yet. And we probably will in the near future, but in the meantime, we could use the sim. Now, the previous connection properties dictionary example worked around this, but you'll hit limitations if things like usernames or database names are different between the test environment and the production environment, which brings us to example number 3 here. In this example, the database and the server are different between the test and the production environments. Now, in SQL Server Enterprise Geodatabases, the database name is actually part of the feature class and the feature dataset name. Now, the reason you need to use the sim is that the managed arcpy.mp API currently doesn't support changing the feature dataset name. For example, we need to change this feature dataset name. You can see it has the test database as part of the name to this, where it has the production database as part of the name. All right, let's walk through this code then. So first, I just set up some variables that specify the test server and database, as well as the production server and database. I specify a project, and for this example, I'm just going to work off the first map in the project, and I'm going to loop through all the layers and look for any layer that is using the old, or rather the test server. And if I find a match, I'm going to update it. So I access the layer sim right here, and then I dig into the sim to the data connection node, and then I update the connection properties, and there's 3 steps, 3 things I need to change. First, I need to update the connection string, and this is just a whole bunch of string manipulation, kind of like find and replace stuff, where I'm just looking for the old server and replacing it with the new server. Then I update the dataset name. So like I mentioned before, I need to replace the test database with the production database, which is part of the feature class name. And again, I'm just doing simple string replace. The same thing with the feature data set. So I check to see if the data is in a feature data set. And then again, I'm just doing some string replace to replace the old one, or the test environment, with the production database. And then I commit the change. So I'm not going to run this right now just for the sake of time, but this brings up the question, how do you know what sim properties to change and what should you change them to? Well, we've mentioned previously that you could take a layer file, rename it to .json, then examine its sim structure in Notepad++. And here is a screenshot of Notepad++ and the relevant parts of the sim. And I mentioned this before, you use the JSON structure Notepad++ as a kind of object model diagram. So you remember my code, I access the sim like this, and then I dug into the sim. So first I got the feature table, and you could see that that is right here in the sim, and then I dig in a little bit more and get the data connection, which is right here. And so this is the section that no matter what type of data format you're using, this will have the connection information. So for example, in my script, I changed the feature data set right here, and there's the value. I changed the workspace connection string, and for Enterprise Geodatabase, it's just a big long string of connection properties, and you just have to go in here and find stuff like the test server, the test database, and update the relevant parts of that string, as well as the dataset name. Now, another example of something that is not easy to do with the managed API is resourcing data from Enterprise Geodatabase to File Geodatabase. And that's this example here. Now, I get asked this question a lot, and I think people have enterprise geodatabases in their offices and they want to give projects to others that are not connected to the enterprise. So this code is very similar to the previous example. And again, we need to use the SIM to handle feature datasets. Now, since enterprise and file geodatabase data structures are different, we need to strip off the database and username, just leaving the feature dataset name. For example, this is what it looks like in Enterprise, where you have the database name, the username, and the feature dataset name. And for File Geodatabase, you just need the feature dataset name, and you want to strip off the other stuff. So this code example, a lot of it's quite similar to the one I just showed you, where I have a variable that defines the new File Geodatabase, a variable that is pointing to the Enterprise Geodatabase. And again, I'm just defining a project and a map, looping through the layers, looking for layers that are using that Enterprise Geodatabase. And then I get the SIM. And I dig into the SIM just like the previous example, all the way into the data connection node. And then I just update stuff in the SIM. So first, I change the connection string to point to the new File Geodatabase. If the data is in a feature data set, then I just do some string manipulation to strip off the database name and the user, just leaving the feature dataset name. This is a little bit different. I have to change the workspace type from SDE, otherwise known as Enterprise Geodatabase, to File Geodatabase, just like this. And then I also have to change the dataset name. And again, I'm just using string manipulation to strip off the database and the user, just leaving the feature class name. Now, one more example for updating data sources. Here's an example to update the map service URL, and this currently isn't supported in the managed API, but using the SIM, it's quite easy actually. So in this script here, I reference the project map and the layer that I want to update. I get the layer's SIM definition, and then in the SIM, I update the URL to the new URL. And then I also have the option to change other layer properties of that map service. So in this case, I'm also going to change the name. And then I commit that change. Okay, so that does it for me. So we talked about the time map series, and then we went through some update data source workflows. Now I'm going to pass it back to Jeff, and he's going to talk about creating new SIM elements.
So this next section is about creating SIM objects. And again, this is something we never fully supported ever in arcpy.mp. Now, we implemented this at 2.5, but we haven't documented it. Now, because this is a developers conference and we like to give developers kind of an idea of things to come and give them a chance to get ready and learn and play, we wanted to expose this to you guys. But at 2.6, we will have complete documentation and examples, etc. But a couple things to notice here. I have a before JSON representation and an after. And this is a really good practice for you to kind of look at the before, create something in the UI, and then generate the after. And what I want you to notice here is that the before does not have a property or a member called background color. And that's another important point, is everything that you see in the JSON isn't everything that you can change. It only persists the things that are relevant to recreate the map. So it doesn't need background color if there isn't a background color specified. But the API will expose all of the possible members that are available to set things inside of a JSON. So how do we go in and create one of these objects? Well, we have at 2.5 the ArcPy sim create sim object from class name. And a class in JSON structure is in double quotes. It's the name of the class preceded by sim, and it also is of a type, right? So type class. So we simply take the value that we see inside the JSON, we use that as the first parameter, and then again we use the sim version as the second parameter. Now we have this RGB color variable. We can set its values to be 130 and 100, as you see here. And then we have a map sim definition, and we can set its background color to be RGB color. So let me show you this. I'm going to move over to ArcMap. I've already modified my map, so I've gotten rid of the topos. And what I want to do is I want to edit this script and just show you a couple of things. So first, I'll just copy and paste this code into the Python window. And I kind of already did it, but msim, and you can see these are all of the members that are available. And these are all the things that are persisted or can be persisted in that JSON structure. And here's background color. Now what I want to do is I want to type, and what I'll know is that that actual background color doesn't exist because it has never been set. If I go to the properties of the map and I go to the background color, you can see that there's no color. So you can't modify the JSON if those properties aren't in the JSON. And that's why you need to go in and create objects. So I'll go back to the script here. And basically all we're doing is if the background color is none, meaning it doesn't exist, then we're going to create that RGB color. And we're going to set it to be 130. If it doesn't exist, just to make things look a little differently, we're going to change it to a different color. So I'm going to run this script twice. So let me execute, click run. And you can see that the background color has been set. I'm going to click run again. And you can see the background color changed because this time it did exist. So I'm going to show you another example. If I go to layouts and I come down here to map series, create new, and click edit. Here's another example of we have a layout that doesn't have a spatial map series set up. So we're going to go to a layout called Great Lakes. We're going to get its definition. And again, we're going to call ArcPy sim create sim object. Now, how did I know it was called Sim Spatial Map Series? Because I authored a map series and I exported the layouts to a page X and I looked at it. I'm taking all of the properties that are required, right? And I'm setting those. And ultimately, I'm setting it back to the layout object. So let me close this. Let me expand Great Lakes. I'll open up this tool and I will run it. So now you can see what I've done is I've gone in and on a layout that didn't have a map series set up, I've gone in and I've set it up. You can see all the individual pages, you can go to layout, and you can see that the map series, spatial map series has been added. So this is really, really, really powerful. But let me come back to the slides and talk about something else. The process of creating these classes can be very complicated. And here's just a simple script that goes in and it creates a line element on a layout. So here at the very bottom, we have the layout sim, and we're adding this graphic that we eventually created to the elements list. But when you have objects that have dependencies on other objects that need to be created, you kind of have to reverse engineer the whole process. So let's look at this. I want to call create sim object from class name. I want to create a sim graphic element, but it has a property down here called graphic, and that's a class, and it's looking for a graphic. So before I can pass the line graphic to my graphic element, I have to, before that, create that. But this line graphic has a dependency, which is a symbol reference. So I have to create the symbol reference. That symbol reference needs a line symbol. That line symbol needs a solid stroke. So whenever you're trying to create objects like this, you really have to understand how to read the JSON structure, and you have to build everything in the reverse order, from the most indented objects out to the least indented. I'm not going to show this now. We will provide more of these samples at a later time. Currently, this does not exist in that collection of samples. But if you really want to start creating more sophisticated objects that really need other objects to render properly, these are the general steps you need to take. So in conclusion, what I'd like you to know is that we're providing as many resources to you as possible. So the basic help sim topic and everything that I've discussed at the beginning of the presentation, and what Jeff has also shown, is discussed here in Python Sim Access. We also have a couple of videos that are slightly different presentations of similar material. And then finally, if you want access to those 30 tools that I've just demonstrated, basically go to this URL right here, esriurl.com 8899, and then look for, this brings you to a bunch of samples, look for the category or the downloadable item called Python Sim Access. Anyway, I really appreciate your time. I hope you've learned something today. I hope you're excited about what you've seen. Give it a shot. Thank you very much.